Hello everyone, in this video let's discuss about the half wave rectifiers. So as the name only tells, half wave rectifiers, they will only rectify the one half of the input signal. So the input signal will be the DC input signal, whether it may be current or it may be the voltage input signal, it will only rectify the half itself. That is, if you give one complete cycle, positive and negative of cycle combinedly forms one full cycle, so they will only rectify the positive of cycle, that is they are rectifying only the half of the input signal. So this is positive, negative of cycle, positive of cycle, negative of cycle. Let's consider this as the given input signal. Now these half wave rectifiers will be having three major components. So they will be having three major components. First one is transformer. So let's design the transformer now. So if you see here, we know that in the transformer we will be having two coils, that is primary coil and secondary coil. Here the number of turns in the primary coil I will call them as N1, and the number of turns in the secondary coil I will call it as N2, and the voltage across the primary coil I will call it as V1. So the voltage across the primary coil will be called as the source voltage. So the source voltage is V1, so I will call it as the source voltage. Next, the voltage across the secondary coil I will call it as V2. So V2 is the secondary coil voltage which will be acting as the input to the half wave rectifiers. See here, this is the input signal wave now. See here, this is the input voltage signal now. So this V2 will be acting as the input voltage signal for the half wave rectifiers. That is, V2 will be acting as the input signal for the rectifiers. Now let's proceed with the components. First one is transformer, second one will be the diode. So we will be using only one diode in the half wave rectifiers. In full wave we will be using two diodes. So I will add diode here. Next, the third component is the load resistor. Load resistor. So now this load resistor and diode will be in series to each other. So both the diode and the load resistor will be in series to each other. Now in two conditions this half wave rectifier will be working, that is in the positive of cycle and in the negative of cycle. So let's take the two conditions also. The first condition is when the half wave rectifier will be in the positive half cycle. Positive half cycle. So now when the positive half cycle will be activated, there will be a polarity across the secondary coil. Here this will be plus, this will be minus. We know that this part of the diode will be called as the anode part and this part will be called as the cathode. Now this anode is directly connected to the positive terminal, that is the polarity positive is directly connected to the anode. So we can conclude that the diode will be positive. So the diode will be forward biased. Forward biased. So when the diode is forward biased, because of the positive terminal and the anode connection, there will be a generation of the current. When the current will be generated, the positive half cycle will be rectified by the rectifiers. So we will be getting the output voltage, we will call it as V out, V0. When the diode is in the forward bias, because of the direct connection of the positive and the anode part of the diode, there will be a generation of the current which helps the rectifier to rectify the positive half cycle. Now if we move to the second condition, that is during the negative half cycle, so the polarity will change. Minus will become plus, plus will become minus. Now if you see here, the negative part or the negative polarity is connected to the anode part of the diode. So here what it will happen is, diode will be the reverse bias condition. So diode will be in the reverse bias condition. Since the diode is in the reverse bias condition, there will be no generation of the current. Since no current is generated, we will not get the output voltage, that is the output voltage will be muffled or nullified. That is, the negative half cycle is not rectified by the half wave rectifier. Now again when we encounter the positive half cycle, so it will rectify the positive half cycle because the diode will be forward biased and we will get the output voltage. Again when you go for the negative half cycle, diode will be in reverse bias condition, you will not get the output voltage because the voltage is not rectified. So this will continue until the signal will be given. Now we discussed about the working of the half wave rectifiers. So let's discuss about the formulas. So the formula will be for V1, that is the voltage source, V2 is the voltage source for the rectifier, and the current I generated. So let's see the formula for all those three. Now V1 will be equal to Vm into sin theta. What is Vm? Vm is the maximum voltage. Here the maximum amplitude. So this height will be called as the amplitude of a wave. So you can conclude that the maximum amplitude will be equal to the maximum voltage. Now V2, that is the input signal for the rectifier. V2 will be equal to N2 divided by N1 into V1. What is N2? N2 is the number of turns in the secondary coil and N1 is the number of turns in the primary coil. So N2 by N1 into V1 will be the value of the input signal for the rectifier. So now let's move for the current I. So if you see here, I missed this part, N2 and N1. If N2 value, that is the number of turns in the secondary coil, are more than the number of turns in primary coil, so you will be calling the transformer as the step up transformer. We know that we are having two types of transformers, step up and step down. So if the number of turns in the secondary coil is more than the primary coil turns, it will be called as the step up transformer. If N1 is greater than N2, then it will be called as step down. So the current value I will be equal to Im sin theta. So what will be the value of Im? Here we got the Vm value through the input signal because the input signal was of the voltage. How to find the Im? So Im is equal to, so you know the Ohm's law formula. What is the current formula in the Ohm's law? I is equal to V by R. So what is the maximum voltage we are having? Vm divided by the resistance sources. Here we are having the load resistance, so I will call it as RL plus RF. So what is RF? RF is the small amount of the resistance which is offered by the forward biasing of the diode for the current being generated. So it will be in the negligible terms, but we will also consider that one also. So now we discussed all the formulas also. If we move to the characteristics, so the main part is of the efficiency. So the efficiency of the half wave rectifier will be equal to 40.6%. So we know that it will only rectify the positive half cycle, so it must be around 40 to 50. So its maximum efficiency will be equal to 40.6%. So hope you understood the concept of the half wave rectifiers. The full video link of the full wave rectifiers will be given in description. You can see it there. And if you have any doubt regarding this topic, please do comment below. I will clarify it. And if you liked the video, don't miss to subscribe. Thank you.